Welcome back, everyone. Today we're taking a look at top K frequent elements, which is an interesting array question on the blind 75 list. So given an integer array nums and an integer k, return the k most frequent elements as the question kind of indicates. You can return the answer in any order. So here we're given this array 1 1 1 2 2 3. There's 3 1s, there's 2 2s, and there's 1 3. So obviously the top with k equals 2, so the top two most frequent elements, the most frequently seen elements are 1 and 2, where we've seen them 3 and 2 respectively. You can return the answer in any order, meaning we can return 2 and we can return 1. So kind of an intuitive solution for this one is to create a hash map. So we have this array 1 1 1 2 2 3. And once we have the counts for this hash map, then we can set the counts, the elements as the keys and the counts as the values for this hash map. So it would look kind of something like this, where you'd have 1 3 2 2 and 3 1, and then from going on, we can iterate through the hash map, and we can sort this hash map by the counts. So we would sort it. So in another list, like 1 1 2 2 2 3, this would be unsorted. So 1 would be 2, 2 would be 3, and 3 would be 1. So then we could go ahead and sort this hash map by the counts. And if we did that, then this would be converted into from top to bottom 2 3 1 2 3 1. So we could convert this map like this. But if we did that, then because we are sorting, not only are we sorting, but we're also iterating through every single one, then our time complexity is going to be O of n log n, which usually isn't that bad, but we can actually do better. So let's take a look at an alternative strategy using something called bucket sort. Now this is pretty similar to what we've done before, but this actually runs in O of n time. And we'll see how this runs in O of n time here. So we have this same map. Given this array 1 1 1 2 2 and 3, we'll have this same map that counts 1 3 2 2 and 3 1. That counts the elements and their counts. Once we have this map, what we can do is actually convert it into a new array of length n, 1 2 3 4 5 6. So we'll take 5 1 2 3 4 5 6. We can instantiate this bucket to be a group of 6 empty arrays inside a bigger array. And now for all these indices, what we actually want to do is we want to put in the indices as the counts. We want the indices to be the counts, not the elements, which is a pretty unique way of thinking about it. Now we have how many characters 1 are there with 0, and actually we want another array here. We want the final index of this to be equal to the length of the actual array. So because this length is 6, we want this to be 6 empty arrays. Now, there's 3 1s, which means in this 3, we should put 1. There's 2 2s, which means in this 2, we should put 2. And there's, I'll put that as a different color. We should put 2, we should put 1, and there's just 1 3. So in this 1, we'll put 3. And if there were, say, if there was a 4 element with a count of 1, then we would include this in the list. And now you can kind of see how this would make things a lot easier, because at this point, then we could just iterate backwards from the bucket, and every time we hit something that has a certain value, then we could push all these values to a list called solutions until we hit a solution length of k. In this case, k would be equal to 2, so we would stop right here. We wouldn't even go on to this 4, we would stop at 1, 2, and we'd return that. And let's take a look at the complexity. So complexity is going to have, the very first thing we'll do is we'll go through this for loop to generate this hash map, which means our time and space complexity are already O of n each. Our time complexity is O of n because we're iterating through, we're doing one for loop through every array, through every index. And our space complexity is O of n because we have a hash map that is that has this many key value pairs. We have n key value pairs in the worst case. Okay. We're not adding anything to the space complexity. We'll have another bucket which is of the same size. It's of max n, and I don't think I explained this earlier, but the reason that 6 is going to be the very last index is because even in the worst case where we have 1 1 1 1 1 1, that means there's just going to be one that's counted 6 times. So the very most that an item can be counted is n times. which is why the length of n is going to be the last index of our bucket. But regardless, we'll make this new bucket, which means our space is going to be O of 2n, and our time, because we're iterating through the bucket backwards, is going to be O of n times n. So these are our, it's going to be O of n plus n. This isn't a for loop embedded inside another for loop, it's just a separate for loop. So O of 2n just simplifies to O of n. Again, same here, O of 2n just simplifies to O of n, which means this is both O of n time and O of n space complexity. Let's see how this looks in the code. So the first thing we'll instantiate is a map, and this is going to take all the elements and their counts as key value pairs. This is going to kind of be part of the intuitive solution as well. So for constant num of nums, then if we haven't seen this new number before, then we'll set it equal to 0. And no matter what, after this, we're going to increment that. So even, what if we have 0, then if we've seen it once, then we'll increment it, so it'll be equal to 1. And if we've seen it once, or however many times we've seen it, then we'll just increment that. So now we should have a map that looks like element count, etc., etc. At this point, we can start working on our actual bucket. So we'll let bucket equal an empty array, but we want to fill it up with a bunch of empty arrays such that the length of this bucket is actually n plus 1. Because remember, we want this last index to be n, and it is 0 indexed, so it should be length of n plus 1. So we'll do a for loop, I is less than num.length plus 1, and then we'll increment. And every time this happens, and this should happen n plus 1 times, we're going to push an empty array into this bucket. All right. Now that we've done that, we can actually start filling up the bucket with count for the indices of counts. We want to start filling it up with arrays of all the possible values that we see. So for const key in map, and this will take all the keys in map. The keys are going to be the elements. So for all these elements, but we don't want the element, we want the value at that element. Then we'll say that the bucket at map key, the bucket at that count is going to be incremented by that key. So we'll push the element onto the count. So that way we can work with multiple elements. And then finally, we can let a solution equal empty bracket, and we can work backwards through the bucket until we actually find the solution length that we want. So for let I equals bucket.length minus 1, I is greater than or equal to 0, and I minus minus, then this will iterate backwards through the bucket, and we only want to consider the buckets that have a length greater than 0. If it's length 0, then we can just skip it. Then we'll let solution equal to, we'll use the spread operator here to copy whatever we had in solution before, and we'll also do the spread operator on the bucket to get everything that was inside the bucket. And then if solution length equals k, or once it hits k, then we're just going to return solution. We don't need another return statement outside of this for loop because it should always have an answer. It's one of the constraints, so this should work every single time. If we submit it, then yep, and that's everything.